Before we delve into the exciting world of science, let's begin with a moment of reflection and spiritual enrichment. To commence our program, I would like to invite Brother Talha to the stage for a beautiful recitation from the Quran.
بسم الله الرحمن الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وزنها للأنام صدق الله العظيم.
Now, let's make sure we understand the profound message. I would like to call upon Brother Mahmood Kamal to provide the translation of the verses.
The Most Merciful taught the Quran, created man, and taught him eloquence. The sun and the moon move by precise calculation, and the stars and trees prostrate. And the heavens he raised and imposed the balance that you not transgress within the balance, and establish weight in justice, and don't make deficient the balance. And the earth he laid out for the creatures.
Let's move on to introduce our school. To do that, I would like to invite my buddy Fatima on the stage.
Wings Academy is an experiential school, the first of its kind in the state, which aims at collaborating individual experiences with syllabus, learning environment, and customized educational options. It is founded in 2018 by Dr. Farha Siddiqui and her better half, Mr. Safar Khan.
Moving forward, it's an honor to have a distinguished guest among us today. I would like to call upon Tuba to introduce our esteemed guest.
Ladies and gentlemen, we are truly honored to have a distinguished guest with us today. Dr. M.M. Nazir Sahab, an esteemed associate professor from New College, Chennai, and co-convener of the National Science Fair. Today, we have the privilege of having him here. Today, to share his insights with us, to honor our guest speaker, I request our school director, Safar Khan sir, to felicitate him.
Without a further ado, I would like to call upon Dr. M.M. Nazir Sahab to the stage for his much anticipated workshop. Sir, the stage is all yours.
Brother Jafar Khan Saab, Brother Syed Akhtar Ahmed Saab, and Sister Khaja Kauzar, and beloved teachers and my dear students. Alhamdulillah, it is a very happy occasion for me. It's a rare, I deem it as a rare opportunity to conduct a workshop first time for the students. As of now, Alhamdulillah, over the 15 years, as we are conducting the science fair, prior to conducting the science fair, we used to conduct the workshop for the teachers. Because science fair is a new concept, the teacher have to be trained and how to guide the students. So we used to conduct the workshop for the teachers. In a year, 5 or 6 workshops we do. Over 15 years, more than 60 workshops we have done. But I really appreciate the organizers here. They felt that a workshop of this kind be conducted to the student. Alhamdulillah, I'm really happy. And inshallah, I will come to your level, so that not that I am talking to the teachers, to your level. I think you all are the school students studying 7th, 8th, 9th, I think, no, that range. So I have chosen the projects of very, very simple projects so that you can understand. Okay, that is the thing. A very important thing is nowadays science is studied as a one subject in school, isn't it? Why do you study science? Why? Why do you study science? Very good. He is giving a good answer. To know about the new things. Any other? Learning? Various phenomena. So, learning science to know the various phenomena, he is telling. See, that is the case actually. The science, by studying the science, so the students have to inculcate certain skill in them. But normally what happens is, science is studied as good as any other subject, like a literature, okay, and at the end of the day, after attending the school, the student will be asked to answer the certain set of questions. They memorize and write. Ultimately, their goal is, when they come to the 10th standard, they should score well so that they get the admission in good higher secondary junior college. When they study the science in junior college, they aim at securing the high mark so that they get the good placement in the higher education, degree colleges. So, by studying the science, what has to be acquired by the student is not acquired. By studying the science, what has to be acquired is not acquired. It's not acquired. Einstein made a statement. You know, Einstein, the great scientist, he made a statement. Nothing special in me than I am passionately curious. What did he say? He is very curious. What do you mean by it? He is eager to know. See, when I asked, why do you study science? One student answered very good. To know the new things. To know the new things. So, basically, by studying the science, one should be very curious to know, should not accept whatever been told. So, the student should be curious to know why it is happening. That question should run in your mind. Otherwise, the purpose of studying the science is not served. And above everything, very important thing as a student at all level, first and foremost thing is, it is not that learning, it's not that a teacher come and teach and he said the new things, teacher and come and explain something, you are understanding, you are memorizing, you are writing. Basically, in an educational system, when a learning is happening, student has to think. You have to think. Thinking is a very, very important process that has to happen as in the class as well as you are reading. So always you must be curious to know why it is, why it is, why it is. So basically, science is a logic. Basically, science is a logic. So when you observe something, a question rises in your mind. Why it is happening? Why it is happening? You look for the reason. When you look for the reason, that is called the logical reasoning, looking for the reason. So by studying the science, you study about the nature. As you study about the nature in various subjects, basically the thing is, you are developing the logical thinking. Why? So that is what you have to inculcate when you are studying science. One good example I tell you, the Newton invented, what did the Newton invent? Yeah. How did he invent? Yeah. Suddenly the apple fall down. Okay. Did the apple not fall before when he stated the gravitational force? Had the apple not fallen before when he observed and stated the Newton's law? Yes. Apple is falling every time, all the time falling. Then how come he was able to come out with a new discovery? Because he was curious. Then another? He was thinking. So he thought. Okay. And a very important thing is, by studying the science, another skill you have to develop is observation. See, he observed apple fall. What is this observation? See, naturally it is happening, he observed. That observation led to the discovery. I look at, I see, I observe. What is the difference? I see you, I look at you, I observe you. What makes a difference? Observing? Yeah, she is telling. So, observing means I look at and I analyze. My mind analyzes. As I look at, now I am able to see how you are, whether you are observing my talk or you are attentive or not. Not that I have look at. Yeah, another question is running in mind. As they are looking at me, do they observe? Are they attentive? Are they showing interest? All that go in my mind. So observation. See, this observation is the key for invention. The observation is the key for invention in science. Okay. Another question. I said the thinking. He thought, he was thinking why. So when the apple fell down, he thought, he put a question. There is called the analytical thinking, comparative thinking. Analytical thinking means comparative thinking. That what the question that was running in his mind was, when a thing is fall, so there is an object. Unless I pull, it will not fall. Unless I pull, it will not fall. But the apple has fallen. Who pulled it? You understand? The answer is the gravitational force. Okay? So comparing is called the analytical thinking. Another one, there is an object on the floor. Why not it go off? Gravity is holding, it cannot, okay. Can't you make an object to go up? What to do for it? What is that force? Kinetic energy. Yeah, energy associated movement is kinetic energy. Okay, when you make a thing to go in opposite direction, particularly in vertical direction, it is called propulsion. Okay, why I am asking this is what is critical thinking. Why not this happen? Why not this happen? When an object can go down of its own, and when an object, why not it go of its own upward? You understand? So basically, by studying the science, you need to inculcate three kind of thinking: logical thinking, analytical thinking, critical thinking. When you have this thinking, no, you will have the problem solving ability. Ultimately, you will get, if you come across any problem, you will be able to solve. Basically, if you have the three kind of thinking. See, normally, how to study science? How to study science? How to learn science? Okay, he is telling that science has to be learned by doing, okay, thinking. See, basically, science has to be learned by doing. See, whatever you learn in science, you have to connect to the life. You will study about the nature, or you have to do the experiment. By doing only, we need to learn the science. It is not that science is not supposed to be learnt like history or geography, like that. We need to. Now, coming to the main point, actually, in schools, normally the science exhibition are conducted, isn't it? Is it conducted in our school? What is the common models and exhibits that you do? What do you? Huh? Hydroponics. Yeah, plant that grow in water. Then? Huh? Okay. Anything else? See, in doing the exhibition, where the things are displayed and models are made that are displayed, but no, as I told, no, by doing the project, how long you take? How long will take to do a project work? Huh? What is telling? A month or two. Oh, month or two, more than that, you are growing the plant. Okay, that's good. Okay. Then by growing the plant, what do you do? See, you are growing a hydroponic plant. Okay, it grows. After 2 months, you come and display. What else you do? Oh, good, good. So he is telling about he is he is actually telling that he is growing the hydroponic plant, and he is comparing with the normal plant, whether the yield is good in the normal plant or hydroponic plant. He is telling, no? Yeah, I come to that. See, generally, this kind of what he is telling, no, That is what is a science fair project. See, normally in schools, like that, what he told, no, the project is not done over the 2 months and the observation is done over the 2 months, not that kind. Many projects are done in a day or two, or even the tailor-made projects models are displayed in the exhibition. So, one should differentiate between what is the difference between the exhibit and, as he said, no, science fair project. When you do the science fair project, how to carry out the experiment, how to record the observation, how to come to a conclusion. Okay, let me give some examples. Yeah, let me take one example. See, he was telling that hydroponic plants as an example of science fair project, and how to make observation, how to come to a new conclusion. So that we need to know. What's the contrast? Slideshow. Okay. I show you one project where student has done a lot of observation. He has made in the form of table and he has presented. Just I will run it fast, then I will tell you how to arrive at that. This is what our objective. Okay. Now I will fastly run this. I will explain it later only. Okay. This is one project submitted by one school from Madurai in Tamil Nadu. He did the project in vermicompost. That is a project. Okay. I'm not giving the fine detail now. So his hypothesis was vermicompost from the vegetable source or non-vegetable source, which will be more effective. That is his hypothesis, comparison. His hypothesis is non-vegetarian source would be better. That is what his guess is. See, he is doing the project. As he is doing the project, he is giving the observation in the form of table. This is one table he has given. Okay. In this table, he is giving when the vermicompost vegetable source alone used, vegetable source alone he has taken, non-vegetable source alone he has taken, and he has taken the different mixtures. So 5 kg is a vermicompost he is taking. That 5 kg can be either vegetables vermicompost or the non-vegetable vermicompost, or it can be composition. 3 kg vegetable, 2 kg non-vegetable source, and so on. Various combination. So you see how many combination he has prepared? Nearly about 3, 10, 13 prepared. he is going to study. 13 composition he is going to study. Okay? You see, these are the fine details. He is doing, as he said, no, the student is growing the plant and observing day by day how much is the growth. He has studied for about, say, 17 days or something he has studied. 14 days he has studied. 14 days study. Every day he has taken photo. You see, this is a one table he has given. You can see, for the 3 kg vegetable soil, okay, he has given this table. How come that people do the experiment and collect so much data, and I share the. I will share. It will not be clear also. Now we have to come to that stage. So what he said, no, hydroponic project is doing, he has observed how many tables he will make. While he is doing the experiment, how many tables he will he has to create for collecting the data. See, here the challenge in doing the science fair project, the challenge is, when you are doing any practical in your curriculum, for example, you are finding the focal length of a lens. Focal length of a lens. You are doing an experiment. It will come now in some standard, 8th or 9th may come. Yeah. Light and lenses? Yeah, come. That time now in the practical book you are given the procedure. You are given a way how to collect the experimental data. You are given the tabular column. You have to collect the value of U. You have to collect the value of V. And then the F is the 1 by U plus 1 by V. Something like that formula is there. And you will be arriving at you are making the table. See, in doing an experiment, and you are given the tailor-made procedure, you are given the tailor-made the tabulation form, something like cooking using a recipe, no? A recipe. So, you are doing the experiment. But in doing the science fair project, what is the thing you are going to achieve is, in doing the project, you are going to propose how the data can be collected, how the data can be tabulated, how many tables will come, everything you are going to tell. So now you are going to create a new, for the project, you are going to do the planning for the experiment, you are going to collect the data. It is your own way you are going to do, not that it is a copy paste. Okay? My question is, in doing an experiment, how many tables have to be tabulated? How to decide it? So one example, just I am making it fast. So he is doing, this is one table, another for the 5 kg he has done, and there is a replication. See, even when a plant is growing one particular plant, he has to replicate, not that he is putting one seed and observe. In one pot, he is putting you see, 6 seeds he is putting, the 6 plant will grow, and he is measuring the length of all the 6 plant. This is called replication. See, when you do an experiment, you cannot do one experiment, you have to replicate. So for this observation, he is putting the 6 seeds, and 6 plants will grow, and he is measuring the length of all the 6. He will take the average. Below that you can see he is taking the average. So various composition he is making the various table. Finally, he is giving the consolidated table. Okay. Now let us study from the scratch. See, in doing an experiment, how to make a table. That is what our objective is. With some example, I try to give you. Okay. Yeah. Yeah. This it is a windmill. Okay. It is a common exhibit in any exhibition. Now, in a science fair project, how it differs from the exhibit is, it is not a model. The student has to do an experiment and to measure and record the data and to arrive at a new conclusion. That is the objective. Okay. See, have you ever seen the windmill in the exhibition? It's a common exhibit. How it is, what is presented in the exhibition about the windmill that is placed? So, windmill is a power generator, isn't it? There is a fan. Okay. When the wind blows, the fan will rotate. That fan is attached to the dynamo. As the fan rotates, dynamo also in the dynamo, the magnet rotates, so it generates power. So this is what is windmill is. You all know about it. You get an idea. What are the components in the windmill? The fan. Yeah, it is attached to the dynamo. As the fan rotates, the dynamo will generate power. That is what. Yeah, I have not seen the dynamo attached to the cycle. You see, in the cycle, when the dynamo is attached, no, as the wheel rotate, the dynamo will rotate and power will be generated. That kind of thing we are not having nowadays. No, that. Okay. So windmill, these are the components. See, how will you do an experiment with the windmill so that you come out with the experimental data? So in an exhibit, they will just show as the wind blows, power is generated. That's all they will show. There is no measurement. But in the science fair project, we do measure. Measurement is a very important part, and in doing the science fair project, because it is a research based project. So you are going to do an experiment and you are going to arrive at a new conclusion. So research means you will be doing something and you will be arriving at a new conclusion. That is what is research. So in exhibit, nothing but they will do something and they will display. There is no measurement, no new information will be arrived at commonly in any exhibit. So to make it as a science fair project, what one has to do is, first when the wind blows, when the power is generated, the power should be measured. How a power generated can be measured in terms of what you can measure, how you can measure, what is the unit for power? Yeah. So in the windmill, you put a circuit. In the circuit, you have an voltmeter, you have an ammeter, and take the voltmeter reading and take the ammeter reading. From its power in watts can be measured. Okay. So one student has done a windmill, and the student now measures what is the power output when the wind blows, and the maximum power that is generated, let me suppose 5 volt. Student has got 5 volt. Now the student think, this is what the research. Research means doing an experiment to arrive at some new conclusion, new innovation. What the student now think is, now he has done a device that gives only the 10 volt, say 10 volt is giving. Now he is thinking that he want to generate 100 volt power. If you want to generate the 100 volt power, what changes he has to make in the windmill? So he has to think. Now if he think and he wants to do some changes in it, and finally he is arriving at 100 volt is objective, this kind of the work is called the research. Research means you are doing something to arrive at some new result which has not been already reported. Okay? Now you tell me, one student has done one windmill, its output is 10. Now he wants to do something, work with that windmill in such a way, ultimately the power should come to the 100. What change he has to make? What change he has to make? Where he has to make change? Anything? I told in the windmill you can see what are the parts, main parts. Oh, one fan is there. Fan is attached to the dynamo, and when the wind blows, the fan rotates, and as the fan rotates, the dynamo generates power. Okay? Now the output is 10 volt. He has to make some change so that the volt increases. Where to make the change? Very good. Very good. What he is telling is the fan size. No, fan has he has done a windmill, the fan has one particular size. What he is telling is, if he increases the fan size of the fan, the output will increase. That is the question. Okay? One. Fine. Any other? Very good. MashaAllah. He is telling that capacity of the dynamo to be increased. Okay? This is another. Okay. Any other? Yeah. It depends on the speed of the wind also. It depends on the speed of the wind. Yeah, speed of the wind. It depends on so he has changed the place. So he observed a 10 volt in a particular location. So if he place it in some other location, because of the speed of the wind, that output may increase. Okay? Yeah, weight is, see, he told about the size of the fan. What the other student is telling is the weight of the fan. Okay? Then what else? Very good. Shape of the fan. So nowadays fan is not flat, it is just tilted. Okay? Shape of the fan. Very good. MashaAllah. Anything else? Again. seam line? Ah, yeah. There should be the wind which is blowing should not be blocked. There should be free flow of air. I tell you, we have come to a very important point. Wait. Say, I told you how many tables can be made for the collection of the data. No? Doing this experiment. How many tables? I showed, now many tables the student did. By doing this project, now how many tables can be made? That I come to it now. See, whatever you told, no, number of the fan, size of the fan, weight of the fan, and the capacity of the dynamo are said to be factors. Are said to be the factors affecting the output. Are you able to understand? Factors affecting the output. So how many factors are there? I have listed these factors, isn't it? Okay. In doing an experiment, next question comes. This is what is research. Thinking to do something and arriving at a new result. Okay. Next question is, in doing what change will contribute more to the voltage? Whether the change in the weight will help you a lot, or change in the dynamo will help you a lot. Can you get my point? See, he has to, he is getting 10 volt, you want 100 volt. Okay, you want to make a change. And size he can change, dynamo he can change the weight he can change, by which will give the better result. He has to do and check. And arrive at a conclusion that by changing the dynamo, the desired output can be reached easily than changing the dimension. He may tell. So that is what is the research is. Okay. Now I am putting on another question. I am taking one by one. By changing the dynamo, to what extent that volt will increase is the one hypothesis. You understand what I say? So there are various factors are there. But my question is, what? By changing the dynamo, how the output will increase is the question. Now coming to the main point. See how he has to do it. Do the experiment now. Yeah, excellent. What one has to do is, whatever he has done, no, everything should be same. Say he has done a one device. So what he has to do is, he has to construct another windmill in which everything is same. Only the dynamo capacity alone should vary. Are you able to get the point? See, to study the effect of changing the dynamo, what he has to do is, he has to prepare one more windmill. And for both the windmill, what should change? Only the dynamo should change, but all others should be same, exactly the same. For the two windmills. Okay? Then he has to measure, and he has to check for the dynamo of this particular capacity, what is the output he has to measure. So this is a basic principle underlying the doing any experiment. See, I told now these are the factors. technically called, these are all called as variables. These all are called as variables. In a technical term, in scientific term, we call it as a variables. And in studying the effect of changing the dynamo, what he is changing, what he is observing? What he is changing, what he is observing? He is changing the dynamo. He is observing the output in watts, isn't it? What he is changing, no, that variable is called independent variable. What he is measuring is called dependent variable. So in conducting the experiment, ultimately you will be measuring the one ultimate one property. That property will depend on various factors. What are the factors on which that output depend are called as variables. And you are changing the one variable and keeping all other variable constant. What variable you are changing is said to be the independent variable. What you are measuring, output, is said to be the dependent variable. Okay, I show you now. This is what we discussed. Yeah. Another. Okay. See, let us consider another experiment. That is, one wants to study regarding the plant growth. Okay. He told about the hydroponic plant. And one wants to study the effect of one particular fertilizer. He is preparing one fertilizer. What I told you in the beginning, no? Vermicompost as a fertilizer. Vermicompost prepared from the vegetable source or non-vegetable source as a fertilizer. One wants to study about the effect of the fertilizer. Okay? How he has to conduct the experiment? Suppose I take an example. One experiment that was reported in the science fair project earlier, I am taking that as an example. One student studied sea waste, the prawn and fish, that waste is there, no? That is normally we throw it away. And he prepared, he washed it, dried it, and powdered it, and choked it in water. And after leaving with water, he collected the decanted water, filtered water. He checked whether that water contains the minerals from the fish waste, whether that can be used as a fertilizer. That is a topic. Okay. Now you are going to do the experiment with that. How will you conduct the experiment? How will you conduct the experiment? So with this example, I will tell you, while doing a project, what are the care you have to take. That I tell you. Okay? You consider that you are going to do this project. How will you design the project? How will you carry out the project? How many tables you can come out? I said no, how many tables you will come out. And in doing this project, again you have to consider all that, what we discussed for the windmill as an example. Now I have come to the effect of fertilizer for the plant growth and another. Tell, like that, what we discussed for the windmill we can. How will you do the project? Yeah. has done the project? Who? Okay. And then how? Yeah. Yeah. Okay. He is telling that he prepared the 4 vermicompost. Let us take the one and do the study. How will you do? I am taking only one. You have prepared 4. Let us take you have taken a one particular vermicompost. How will you do the experiment? That is what we are talking about. Yeah, he is telling which one is beneficial. And then see which one is beneficial in the sense there should be a measurement. There should be a measurement. What is the measure for the beneficial? Very good. Growth of the plant is the good. Okay. Then when you are doing the experiment, you tell, okay. What else? How you can do? What care we have to take? Same type of? Correct. See, in doing this kind of project, what one has to do is, he is telling that he has dug the pit in the ground and he has done it. For the purpose of discussion, let us consider it is grown in a pot for the simplicity. Okay? And the other first experiment I showed no, that was done in the ground. Naturally, by digging the pit, the project was done. Now let us consider we are doing the experiment in the pot. Okay? Then how will you do that? How will you compare the growth with the fertilizer, vermicompost? Yeah. See, now again we have to go back to that. Plant growth depend on what? A plant grow, the plant, what are the factors that are affecting the plant growth? Yeah, one sunlight, then wait. Water, nature of the soil, then nutrient. So that is what we are checking, whether the vermicompost shall be nutrient. Okay. Anything else? So what else? Water, sunlight, and the nature of the soil. Anything else? It is exposed to the atmosphere. Same. Then, see, all these are said to be the factors. All these are said to be the factors affecting the plant growth. All these are technically called as the variables. Okay? Now you tell me, in doing this experiment, you have to vary one variable and you have to observe the output, while you have to keep all other variable constant. This is a basic principle in doing any experiment. Okay? There are many variables associated in an experiment. In doing an experiment, you have to keep all the variable constant. You have to vary only one, and you have to measure the output. 2 variable, and all other as a constant. In this experiment, what you are varying is called the independent variable. What you are measuring is called the dependent variable. Other things you are keeping it as constant. In our experiment, what we are discussing, can anyone tell what is a dependent variable, what is the independent variable, what are the things to be kept constant? See, anyone want answer, raise your hand. then I select. Anybody else? You are repeatedly answering, only 2 or 3 are repeatedly answering. Anybody else want to answer? My question is, what are the factors I listed? No, that is nature of the soil, sunlight, watering, and so on. Okay, and we are having the vermicompost also. That also affect the plant growth. In this study, what is dependent variable, what is independent variable, what are to be kept constant? 2 are ready to answer, this boy and that girl. Leaving these 2, I am expecting anyone to answer. That boy is always ready. Okay, now you tell. You tell. Huh? And now I am talking about the next project, plant growth. Can you tell? Be louder. Which is dependent? Huh? Yeah, growth of the plant dependent. Okay. Then independent. Yeah, compost. That is what we want to study. By changing the compost, what will be the growth? That is what our aim. So that is independent variable, and responding is, that is what you want to measure ultimately is plant growth. That is dependent variable. You have to keep everything else constant. So in doing this experiment, what one has to do is, you should have the minimum 2 pot. You should have minimum 2 pot you should have. In the one pot you take soil, another pot also you take the soil. Okay, you whatever the plant you want to grow, say maybe the tomato, whatever it is, the same number of seeds you put in both. Okay, everything should be same for both. Okay, and only one difference must be, in the one pot you don't only the soil, and another pot, in addition to the soil, you add the fertilizer or the vermicompost. Okay, otherwise everything should be kept constant. And both this pot should be kept at the same place. Why? Same sunlight. When you put the water, same quantity of water. So everything should be same. Only one variable you have to change at a time, and you measure the output. Okay, this is how. Is it okay I do with the only the one pot, that is called control. One pot with the soil alone, and one pot with the soil along with the vermicompost. So I am comparing. Then only I will come to know whether the vermicompost really helps the plant growth. Is it okay? Shall I proceed? Okay. Anything else has to be done here? Suppose you are growing the one pot normal soil, one with vermicompost. Accidentally one pot it has fallen and broken. So you would have done the experiment over a time. At the end, accidentally one pot get broken, then the whole project goes waste, isn't it? What can I do now? Huh? Very good. He is realistic. You have to start again. No, there go. So to overcome this, what? In science, one time measurement is not reliable. Don't rely on one time, doing anything by one time. You need to replicate. That means you need to replicate, in the sense, you want a control, that is a plant with only soil. No, you do with the 3 pot. You do with the 3 pot. Instead of taking 1, you take the 3. And another set, this is called set. 3 pots where you are taking only the normal soil is called control, for comparison. another 3 pot, okay, where you take the normal soil, the same quantity of soil, same soil, but along with the vermicompost. Okay? Is it okay? It is a one key point in doing the experiment. You need to replicate. What will happen? Finally, you are measuring the plant growth. What will you measure? What will you measure? Height of the plant, number of the leaves, isn't it? All that you are measuring. And for the 3 plant you are measuring, isn't it? You will have the 3 value. Whenever you replicate, and if you replicate 3, you will get the 3 value. If you replicate for 4, you will take the 4 value. Which value will you take? Shall I take the highest value? Excellent, average. Excellent. Whenever you replicate, you have to take the average. Very good. Okay, let me show you the this is what? What are the factors affecting nature of soil, watering, exposure and fertilizer? What can be measured as a measure of the plant growth, length of the stem, number of leaves, size of the leaves also you can measure. Okay. Control and experiment. When you do over a period, you should have the 2 set. One without the fertilizer, one with the fertilizer. One without fertilizer is called control for the comparison. Okay. I am showing you the data that was collected by the school student. Okay. What is this? First table, are you able to see? He has recorded control. There is a one set. Date of the seed sown and date of germination. After what time, how many days the sprout come. Okay, date of germination. Finally, the growth is recorded. For everything, he has noted the mean also. Mean means average. Okay. And the next table is, that is for the brinjal. So, the brinjal with what? This is the experiment where sea waste is used as a fertilizer. I said no, sea waste, the solution is prepared. That solution concentration he has varied. Concentrated solution he has prepared, and then the student has diluted to 5%. Are you able to get my point? The project is, he is testing whether the sea waste can be used as a manure. He is taking the 10 gram of the sea waste, he process it, he treat with water, and he filter it. Whatever the filtrate comes, he uses as a fertilizer. That is a stock solution. If the stock solution cannot be used as such, too much of fertilizer also disadvantage. So what the student has done is, what percentage of the solution will be optimum for the maximum growth. That is his study. Now what he has prepared is, he has prepared 5% solution, and he has prepared 10% solution, and then he has prepared 15% solution. So as he is changing the variable, as he is changing the independent variable, how he changes, for the each change one table comes. Can you get a point? So he is changing the amount of the fertilizer, and he is studying the growth. For the each amount of the fertilizer, one table is reported. Okay, you can see the for the 5%, this is the table. finally at the end only it can be. Yes, not report, yeah. See, the length of the route can be measured, and see, the project is planned for a certain period of observation. The period of observation is, you can fix it as a 14 days observation or 3 weeks observation. At the end, it has to be routed out and the route has to be measured. It is reported for 5% and 10%. See, by doing this science project, what we are discussing, in doing this science project, you are following the scientific methodology. There is a call in doing a research, something called the scientific method with which a research has to be done. In doing the science fair project, what we are trying to make you to do, we are trying to make you to do the project following the scientific methodology. You don't think it is so simple. It is a scientific methodology with which any scientist work. Even the Chandrayaan was launched, even that research also follows the same methodology. Whether a scientist work in ISRO or anywhere, any scientist work, they have to follow the same method. So what is a method that involves the, basically, these 5 steps. Basically, these 5 steps are the basic method for doing any research-based project. Okay, what I am discussing now, all that. First is, we observe. We observe. When you observe, a question rises in your mind. You identify a problem and you want to bring a solution. Okay, so the observation is the key first, and you have to raise a question. So we were discussing, I was telling, in the windmill, the student want to know by changing the watt, change, the voltage can be increased to the expected extent. Like that question. Okay. Next, third one is the observation, and then question, and then hypothesis. So hypothesis is, before you start doing the research, project work, you can guess what will be the result you are anticipating. What result will come by doing this. A student is doing a project with vegetable based vermicompost as well as non-vegetable based vermicompost. He guess the non-vegetable based vermicompost may give the better result, maybe the better for the plant growth. It is his guess. So hypothesis means educated guess. He guesses. It may not be true also. So he has to do the experiment to find whether it is right or wrong. Okay. Then to test the hypothesis, he designed the experiment. We were talking about designing the experiment. I gave the example of windmill and the sea waste project. Okay. And then he collect the data. After collecting the data, you will analyze. You will compare and you will analyze. After analysis, you will come to a new conclusion. Oh, this is what will give this result. It is totally a new conclusion. Then it is called a research project. Okay. So when you are presenting the project, these under this heading you will be presenting. normally when you select the project, no, we are expecting you, the school student, to do research. The research is something great, no. The scientists are doing research. How come that school student can do the research? What is expected from you? What is expected from the at your level? What is expected? Not that you are not going to invent a new concept. That is not expected beyond your level. Not even a new application. There is one concept that it can be applied. Not even new application. Even that existing application, if you apply to a new situation and you are able to solve a problem, that is a good project. Okay? See, when you select a problem, when you select a project, that should give a solution to the problem in the surrounding. Problem in the surrounding. That is a good project. Okay? See, by doing the, you should not do something which is already established. Which is already established. For example, by varying the pH of the soil, plant growth will vary. It's already known. Why should you verify? So already established one, you need not do it. That cannot be a project. See, always discovery two kind. One accidentally discovered. Another one you can plan, do the experiment, observe, or you can discover something new. This is the one source where you can get the various title. What are the problems, what are the topics you can do the research. The National Science Digital Library is a one source you can look into. Okay. There are many references are there. I can give you the list. Actually, see, if you select any problem, any project, when you selected a problem, when you start doing a science fair project, you have to study complete background about the project. Suppose you are doing the windmill, means related to the power generation, you have to study in depth. Okay? Normally, in your curriculum, in your schooling, you will be studying the something about many things. But if you select one particular topic, you have to know everything about something. You have to learn much about it. Why should you? Tell me. If not, you are learning in depth about the topic selected, what will happen? What will happen? Yeah, first thing is you have to understand the concept. Okay. Even if you understand the concept, why should you deeply study? Yeah, related to the topic, you will have the many queries, you have to study more. You have to know about it. See, you suppose the power generation, you have selected the topic. Related to power generation, you can refer to the textbook. Little higher than your level. See, you are studying science, there is a level for you. Advanced concept you are not studying. But when you are selecting something as a project, then you have to learn more than your level. You have to go to the higher level to know the thing. I am expecting one answer from you. Yeah. Very good. So, related to the project, there will be many problems that you have to know. I am expecting one answer from you. No doubt should be there. Yeah, no doubt should be. See, very important thing is you want to study about the effect of the vermicompost, isn't it? Can you, while watering, you are adding the same amount of water. You are exposing to the same amount of sunlight, isn't it? You are taking the same soil, same quantity of soil. You are controlling. See, you have to understand what are the variables and what are to be kept constant in control and the test. If you are not having the thorough knowledge, you will not understand all the variables. You will miss one variable which you may not control, that will give the wrong result. So, if you take up any project, whatever the thing you want to study, what is to be measured, what are the factors affecting the output, you need to know it. If you are missing one variable, it will give the wrong result. So, you have to study in depth. Okay. This is a very simple experiment that will give an idea about understanding the variables. Okay. Boyle's law, have you studied? Boyle's law, Charles' law about the gas. Do you come across at this level? Not this. Then I skip it. I will have to explain much. Yeah. This is a very good example. Are you able to see? See, I am going to purchase a laptop. Okay, new laptop. I am making inquiry. I am collecting the data. The three brand, Dell, Lenovo, HP. Three brand. I want the specification, size, hard disk, battery capacity, what type of battery, other features, and all I am comparing. I have to come to a conclusion which I can purchase. You recommend me. Yeah, you get my point. So these are the feature I want. Size, the laptop size, hard disk capacity, battery, what type of battery, and many more are there. All other are same. All the three brand. Now comparing the cost, which I can go for? Lenovo. Second one. Oh, yeah, as one as you. Wait. Any other? Which I can? But I am very cost conscious. I want to go for the cost effective one. Okay. Generally, we used to go for the. Tell me. Wait. Any other answer? Lenovo. Okay. Any other answer is there? One is telling Lenovo. He is telling HP. You tell me why HP? Yes, you openly tell. See, I tell you one thing. You must speak, you must raise question in the class. That means when you are raising the question, you are thinking. When you are thinking, you are learning. Even if you do the mistake, no problem. Even if you tell the wrong answer, no problem. Okay, but you should speak. Very good. He is, in a way, he is right. He is telling it is a least cost. But he is telling that although it is least cost, we should not go for the HP, we should go for the Lenovo, he is telling. Why?
Because it's giving 1 dB and all the same features in 28,000 and the lower one is giving 0.5 dB in the same.
Yeah. Okay, you are not able to hear.
The difference is of only 2,000.
Yeah. See, you are also right in a way, but see, HP is the lowest, that is 25,000. But when you compare, no, as I told, no, all the feature must be same. your intention is you are going for a brand. You are varying the brand, you are looking for the less cost. So varying the brand is the independent variable. So you are looking for the cost, that is a dependent variable. All other must be constant, then only you can compare. Okay, when you compare the two, first and Dell and Lenovo, all the features are same. Only the brand changes, all other feature constant, the cost you can compare. That is reasonable comparison. Okay, when you go to the third one, when you compare all the data, not only the brand you are changing, the memory and the artist's memory also changes. Then you cannot take a decision. You understand? So this is an example. This is an example of what I told you. When you are doing an experiment, you have to keep everything constant. You have to change the one variable. You have to change the output to be measured. I tell you the incident in the life of a scientist. Okay. You know the MRI. MRI. So for the patient diagnosis, MRI is used. The MRI is invented by a scientist. The basic principle of MRI is a NMR, nuclear magnetic resonance. That was invented by a scientist called Isaac Rabi. Isadi. Isaac Isadi is a scientist's name. He invented NMR. He got Nobel Prize for that invention. The media asked the question to the scientist. See, when somebody is making achievement, people come and take the interview. Now the Chopra, Neeraj Chopra won the world prize, world champion, no, in throw, javelin throw. The media come and interview. Oh, what's the secret of your success? The scientist was interviewed. He told, the question is, who made you how you became the scientist to the extent clinching the Nobel Prize? The answer was, you tell me what you would have told. Who is responsible for him to become a scientist? Or what you would have told? Teacher. Normally, even the Abul Kalam, no, he told, he was asked, I am a great scientist today. The man who was responsible for me to become the scientist is my teacher. Okay? And he also named one Iyengar teacher. He is a Brahmin teacher. But what he told, no? It is my mother who is responsible for me to have come to this position. So, what did he tell? Who is responsible? Mother. But mother is not a literate. Mother is not a scientist. So the media person were admired. How come that illiterate mother can make you a scientist? What he replied, no? Every day when he was boy, every day when he go to the school and come back, the mother used to ask one question. Regularly she will ask one question. Can you guess what the question should have been? Normally, what is the question asked when you go back? What your mother asked? Huh? What did you do? What did you learn? What else? What? How was the day? Okay. You know what the mother asked the boy? Very important. She used to regularly ask the boy, what question did you ask the teacher? What? What question did you ask the teacher? You understand? See, why the mother expected the son to ask the question? Why? Develop thinking. I told you what is special in Einstein. Yeah. See, when you ask any question, that reflects the curiosity. How curious you are. You are very eager to know the answer. Not that you later you can ask. Immediately, they are very curious. There was one incident in the life of Einstein. Einstein, the great scientist. At the time of his marriage, everything is arranged. And nikah, time. No? Einstein was missing. He was not there in the search. Everyone looking for the marriage is going to happen, that time they are looking for, he is not there. Then they all thought where you would have been. If he is not here, where you would have gone? The people went to his lab and found him doing something and asked him, why you have come there? Everything is ready for the marriage there. Why you have? I got an idea. I wanted to test it immediately. So curious. Okay. Then let us come to the point. Yeah. See, this scientific methodology, what we are talking about, no, is not in our curriculum. But in advanced countries, the scientific methodology is there in the 4th standard textbook in America. In the 4th standard boy or girl, in the 4th standard itself, what we are talking, they learn. How the scientists work. You see that? How scientists work. This is pages from the standard 4. Planning and investigation. That is what I was talking to you. Designing an experiment, planning an experiment, investigation. Step 1 is the asking question. Say the question, he is asking what soil works better for a marigold plant. Is the question. He goes, then the hypothesis. The one student think for the marigold, the potting soil may be better. The student thinks, guess. That is a hypothesis. He plans experiment. How he plans experiment? 2 set of 3 pots. One with the normal soil, another with the potting soil, and the comparison goes. And then he conducts the experiment, he measures. He measures over the 21 days. Then come to the conclusion, the potting soil is as good as the normal soil, no difference. Okay. One more thing. See what kind of project win in any science fair or any competition? What do you think how good, what is the measure for goodness? What kind of project you think will win? Project of new concept, new idea. What he is telling is very, very important. It is idea that wins. The idea that wins. Okay? Any other? What kind of project win? Innovative. Yeah, innovative. Okay. Wait, someone else. Yeah, same people are answering. Other you keep, you tell something, maybe wrong, no problem. Huh? Curious. Okay, curiosity in learning. Hmm? Ah, beneficial to the society. Yeah, useful. Okay. See, you think one more. Uh, which? No, what she is telling now. Yeah. What she is telling is any new idea that gives solution to the real time problem. She has really understood how a project supposed to be. Okay. And some people think only that project that is done with sophistically, technologically sound project alone will. Don't think that the project should be the one for which the one has to spend more. Then only the project will be good and it will win. Now I show you one project, one example that has won prize in the International Science Fair. It won prize in the International Science Fair conducted in Los Angeles. Okay? You see, the idea is not the one very innovative. But the idea is simple. The way the student conducted the experiment, collected the data, following the scientific methodology, validating the result. She is coming out with a result. That result should be validated, supported with the data collection. But idea is so simple. See, the project is normally the water is contaminated. Water is not clear. To make the water clear, what one has to do? Enna pannum? What? Water filtration. Wait. For the water filtration, what material can be used? The problem is, the student has selected a problem. Water is in our neighborhood, the water is contaminated, not turbid, not clear. We are not talking about the germs. We are talking about the suspended particles, not clear. Okay? How to make the water clear? It's a filtration. Then one has to look for what is the filter material. You are telling what are the filter material can be used? Charcoal can be used. Pebbles can be used. Mesh can be used. Cloth. Normally the cloth is used. Okay. See, we are thinking the solution is very simple, cloth, isn't it? One student has done a project with the cloth only, won the international prize. Nothing new. She has demonstrated that the cloth is the most effective for filtering. Then what cloth it is? That is the question. Yeah. Here is the, wait. See, here is the comparison. I said not standard. For the water to be clear, there is one unit, a nephrometric unit, NU. There is a ISO standard. If the nephrometric, if the water is analyzed, if the nephrometric unit is below certain value, that water is good for potable. You understand the point? For the water clearness, there is a unit, turbidity unit, and that is given in terms of nephrometric unit, NU value. When it's below the certain value, then only you can use it. If you filter with pebble, if you filter with ordinary cloth, that standard will not come. But to our naked eye, it may be clear. Still, it may be having the minute particle. but the student has done with the cloth, but shown, done experiment and proved that the clearness is below the international standard. Nothing but jeans cloth. What it is? Jeans cloth, no? Jeans cloth. The denim jeans cloth. That student has proved that is most effective as a filter. And of course, she has designed the experiment in an innovative way. You see that how innovative the work is. This is the design. Are you able to see? Can you guess what it is? Water filter. Now it is not something. It is made by her. With what it is made? Can you guess? Nothing but she has taken the bottle. She has cut it. Okay, this is the one part. You can see. This is the one part. In the part, this neck, no, she has choked with the, what is a filter material? She has choked with the jeans cloth, denim jeans cloth, in a folded manner. There are one fold or two fold or three fold or something. She has cut, this is the one part. You can similarly you cut another bottle. You put it over it. Cut another bottle. Put it over it. The series is what you are seeing. So this is an innovative idea. So for the filtration to be more effective, she has replicated. Okay. Yeah. In this, you see the various materials she has tested. Last one. She has tested with the sand, foam, ground and sieved charcoal and t-shirt fabric. She has tested all the fabric. Not only jeans. Ultimately she has arrived at. She tested the t-shirt fabric, coconut fiber. That also she has tested. All that she has tested. Yeah, nephelometric turbidity unit, NTU value, is a measure of presence of suspended particles. WHO standard, she thought below to that standard she has to bring in. So she has analyzed silk, denim, cotton, fleece, microfiber, polyester and so on. Okay. Finally she arrived at denim gives the best result. Okay, now the question comes. Now you tell me, you take this as an example. Yeah. Now you take it as an example, you tell me, for the filtration to be more effective, what are the variables? Wait. See, what are the variables that affect the clarity of water? Okay. Let more students. No, now we have arrived at denim cloth. Denim, jeans cloth, one cloth is selected. Now we are going to do this experiment with this design. Now you have to tell what are the variables that affect the ultimate clarity of the water. Not you. Not you. Always. Some other guess. Why this side is so silent? You can guess. What are the factors affecting? Wait. Yes. Yeah, type of cloth is a variable. Now we have narrowed down. She has selected many and finally she has come to a conclusion. Denim jeans cloth she has selected. With that she is going to do this experiment. For this design, what are the variables? Like what we discussed the windmill. Windmill, no, what are the components? So on what the output was dependent on? Any other? Yes? Huh? Quality of, very good, quality of the denim cloth. So brand varies, quality varies, very good. Super. Anything? Any other? Now you tell. Huh? Excellent. Amount of the filter and amount of the filter cloth. In this design, where the amount of filter cloth come? In this design, see how many bottles are there stacked? No. Bottom is the collector. Above that are 1, 2, 3, 4 are there. Okay. You mean only the 4? In each bottle there are folds are there, isn't it? Some folds are there, so that it depends on the number of the fold and the number of the bottle. So these are the variables. Excellent. Super. Thickness of the cloth. Okay. Thickness, it is also there. Okay. Fine. Anything else? Anything else? I show you. And whether used or unused, how old the cloth is also matter. Okay. Yeah, number of levels in the tower, different quantities of denim layers over each spout, using new versus old denim cloth. She studied in different ways. Actually, the project simple, isn't it? Even we can do. It is not that it has to be done in America, but this project won the International Science Fair Prize. Yeah, Lebanon Foundation conducted in US, Portland, USA. The price was $100 as a prize. Another student presented in the International Science Fair, again nothing new, only the ordinary cloth as a sari cloth as a filter for bacteria. Sari cloth as a filter for bacteria. Okay, fine. I end up this.
Not in groups, you have to discuss it with him. Yes, in groups you have to go.